Hello, we are going to continue to speak about Posicast control. This is the journey video 5. We are going to address the Gantry-Crane control, but in this case you are going to use considering closed loop control with the half cycle. So the configuration that we are going to use is this one. So now we got the half cycle Posicast is this part here. So this is going to show that we have a step as a reference signal, and this step is going to be shaped for a different signal, which is going to be the new reference signal to the closed loop system. So the closed loop system is this one. Now we got a proportional controller, and we are going to consider a proportional gain of 10. So what you want to control is the position of the trolley and indirectly the oscillation in the cable. So we are trying to reduce the oscillation in the cable, the final oscillation of the cable. So the settings for the Posicast are this one. These are the amplitudes of the steps 1 and 2, and these are the transition time. So the second step is applied in this instant. We are going to consider the step input here at 0 seconds from 1 meter. This is 1 meter amplitude, and we are going to consider a disturbance of 1 Newton a step applied at 6 seconds. I'm not going to speak about how these settings were obtained for the half cycle, but you can find more information in this paper. And we got here the result of a simulation. So in the top plot we got the angle in radians, and in the bottom plot we got the position of the load, and we can see here that okay, it reaches 1 meter, and then when we got the disturbance at 6 seconds here, you can see that because of the proportional controller we have a steady state error that we cannot get rid of. We got this offset of the signal, and because of this is illustrative, just to show we have to move for another controller. So I'm going to show you here that okay, here the movement is in this direction, and then it reaches the final position, and then you got a disturbance here that you cannot get rid. So we got here in white, we can see the final position. We can see that also in the, if I can open the video. So as you see, it reaches 1 meter, and then we got the disturbance, which is going to happen here, and okay, it doesn't compensate the disturbance at all. Okay, so moving on to a more complex controller, a PID controller, that I'm going to speak also in the later videos. Now we see here in the block diagram, this is the half-cycle Posicast, as we have seen in the previous slide. This is the reference, it's a step, and then we got the disturbance here with this amplitude. So the settings for the Posicast are these ones, and from the PID controller these ones. We are going to see that these gains are quite aggressive, so we are going to really provide an aggressive response for the system. And so we can see here that okay, we in this part this is not really a perfect response, but the disturbance is compensated. As you can see here, it moves away from the final position, but then it recovers again, it returns to the 1 meter position. So as you can see here, due to there's a big patch movement here, because it moves to the intermediate position somewhere around here. This is the initial position, and then to the final position it goes to this part and returns again to the final position of 1 meter. So the final position here, you can see that is really in 1 meter. Okay, I'm going to show you the video, and the video is okay. So you can see a big oscillation, and then he goes to the final position and fast he positions the trolley. So this is quite nice, apart from the wide oscillations that we cannot have, as you are going to see in the next slide. I'm going to close this. Okay, so I've done a comparison between the model, the linear model and nonlinear model. As you can see, for in this case, for these settings, there's a in the linear response is in black, the nonlinear response is in the dash red, and we can see there's a big error between the two models, so this is not acceptable. So we have to use another gains. This is because of the oscillation of the cable. And so new settings are these ones. These are for the Posicast, as you can see here. These are for the proportion PID controller. And we are going to repeat the simulation as you can see. There's a perfect overlap between the linear and nonlinear model. So we can see that in this case, with this controller gains, the linear approximation is valid. And you can see also here, because that movement is softer, okay, it doesn't, this one, and the final position is this one, and okay. I'm going to show you the video again, and you can see that it goes to 1 meter. Then at 6 seconds we get the step disturbance, and then it recovers again for the 1 meter. This is disturbance, returns to the same position, and that's it. It works. Okay, so with this video, I conclude this talk, and I hope that you enjoy this presentation. In the next video, we are going to speak about other types of Posicast, not only half cycle. Okay, thank you.